So when we solve quadratics, we have a lot of different ways that we've solved a quadratic equation before, okay? But the good thing today is that our focus today is only quadratics. So we're not going to have linear functions, which we focused on a lot already. I think they might throw like a cubic function in here, and I don't really know why that is thrown into this section, but for the notes part, I'm only going to talk about quadratics, and if we end up with a cubic, we'll talk about that. That'll be more down the road when we talk about other polynomials. But today, we're going to be solving just for quadratics. And so we're going to have a function that looks like that. Quadratic, and we've talked about graphing it, and we know it's a parabola, and we are going to use our graphing calculator today. So if you want to get your graphing calculator out, we are going to use that a little bit to graph, but we're also going to talk about other methods of getting there, okay? The goal today is to solve. So when we solve, we're going to set the function that we have equal to 0. And then we're going to solve it. And we did that with linear equations. Like if I had a function like 3x plus 2, and the first couple of chapters we said I could simply just set it equal to 0, and then I could solve for x. And we call that the solution or the 0 of the function. But today we're going to do it with quadratics. We're trying to figure out what value of x can I plug into that function that makes it equal to 0. Okay, I'm going to show you a couple of different we could do it by graphing, and just so you know that these are all going to be the three different types that we could see. If I said f of x equals x squared minus 9. If we were to put that one into our calculator, it would look something like that. Okay. So it's a parabola that comes down, it crosses the x-axis in two different places. And so in this one, we would say x equals plus or minus 3. So I could end up with two solutions in some cases. Okay, another way, or another type of graph that we might see is x squared minus 6x plus 9 equals 0. Okay. If I were to graph this one, and there's nothing wrong with putting x equals 3. So you don't have to have two solutions. A parabola, a lot of times, will cross the x-axis twice, but it doesn't have to. In this case, it comes down, hits it at 3, and comes right back up. Okay, the third possibility is where we're going to bring in what we did yesterday. We have an equation like this, x squared plus 13 equals 0. If I graph this one, so in order to find the solutions here, if I were to just graph this, okay, obviously what we said is this is no real solution, but that's not going to be acceptable from here on because we know there is an actual solution. We want to find that solution, and that's where our imaginaries will come in. So using what we talked about yesterday, first thing I'm going to do here is I'm going to solve this equation for x. So I'm going to subtract 13 from both sides. And then I'm going to take the square root of both sides. And when I simplify this radical, what we said yesterday is the square root of -1 is really an I. And so the way we were going to write our answer here is plus or minus I radical 13. And those, whenever you have an imaginary solution, and we'll talk about this more in depth later in the chapter, but they always come in pairs. You're never going to have just one imaginary solution. If you have an imaginary solution, it always comes with another one. And so that's why we put the plus or minus on it. You'll always have two. Unfortunately, there's no way your calculators, as of right now, maybe in the future, maybe they'll be able to do this, but for right now, there's no, button in your calculator that you can find the solution on that, like from your graph. It doesn't tell you the imaginary solution. So we have to know how to be able to do those by hand and know how to find that, and we're going to talk about that kind of throughout the day today. Okay, so we could graph it. I just wanted to show you what the three different graphs would look like. So we could have two real solutions, we could have one real solution, or we could have two imaginary solutions based on how our graph looks. So we call that the first method of factoring. We're going to talk about like 5 different methods today of solving a quadratic equation. So the second method, I'm just going to label this method 2, is factoring. First method is graphing, second method is factoring. And there's a lot of different factoring that we've done before. This one is Dobbs, right? X squared minus 49. Because x squared and 49 are both perfect squares, we could factor this into x plus 7 and x minus 7. And then we could set both of those equal to 0. And that would be our answer. And most of you, and I'm going to keep drawing that relationship here, right? If I were to graph this graph is going to cross as 7 and -7. And I know most of you would say, well, I would just prefer to graph this and put it into my calculator and see where it crosses the x-axis, okay? And there's nothing wrong with that, but there's going to be some times where that's not always going to work, okay? And so I'm just helping you to understand that there's going to be more than one way that we're going to be able to solve some of these. And in some cases, it's going to say solve whatever method you want. So if I gave you this one and I said solve using whatever method you want, then graphing it would be a piece of cake. We could put it in our calculator, and we could see the two places it crosses the x-axis. All right, so this one, we call this one DOPS, difference of perfect squares. It's one of our types of factoring that we've done. Okay, another one. X squared plus 6x minus 27 equals 0. We haven't done this yet, this year. But we've talked about a lot about factoring in the past. So it's just one of those skills that we haven't really kind of reviewed just because of time and where everything falls. But we've got to factor this. And when we factor this trinomial out, what I call this one, and if you've had me in class, you've probably heard this, and maybe some other teachers use a little bit different terminology here. I call this product and sum. And the reason we call it product and sum is because product means I'm looking for two numbers that multiply to get -27 and at the same time add to get a +6. So I'm looking for two numbers that make both of those things work. Product means multiply, sum means to add. And once again, when we factor it, we're going to write out the two sets of parentheses that would factor to get that polynomial, that trinomial. We know that x times x gives me x squared. What two numbers multiply to get -27 and at the same time add to get 6. 9 and negative 7. So this would be, and it doesn't matter which one goes where. Hey, once again, just so you understand what's going on here, if I FOILed this out, this would get me back here, right? And that's the whole purpose of factoring. This FOIL gets me back here, but now this is a whole lot easier to solve because now I can set both of those equal to 0, and I get x equals negative 9, x equals positive 3. Okay, and once again, just so you kind of understand, if I were to graph this one, it would cross the x-axis at negative 9, positive 3. So the x-axis are what we call the zeros. Those are also the solutions of the equation. So graphing this would be a pretty easy way to graph it, right? And a pretty easy way to solve it. But we can also get the answer by factoring. And you might say, why would we ever need to factor? Well, there's going to be some times where factoring is going to come into play that graphing may not. Okay, and we'll talk about that later on. Okay, so I call this one the product and sum method. It's where we have all three terms, but we don't have a number in front of the x squared. Okay, the third kind of factoring still a trinomial. Okay, that's going to be the common theme today, is that most of these are going to be trinomials. They're all going to be quadratic. But the difference here is we have a number in front of m squared. So because we have a number in front of m squared, I can't do product and sum, because product and sum, we don't have a number in front of the x squared or the m squared. Anybody remember the factoring method we use on one like this? Slide and divide. Yep. Good old slide and divide. Okay, so slide and divide is kind of similar to the product and sum, except instead of my product being this last number, we got to multiply the first and the last number together. So my product here is going to be a negative 10, and my sum is still the middle number, which is 3. But it's still kind of the same idea. We got to find two numbers that multiply to get negative 10 and add to get positive 3. What two numbers would make that work? Okay. So when we write this out, okay, I'm writing a division sign here because it's not just going to be 5 and negative 2. What we have to put right here is our leading coefficient. Okay, our leading coefficient here is 5. So whatever, and that's why I underlined this at the beginning. That's the difference here. So we got to divide both of those factors by that leading coefficient. If it reduces, we can simply just reduce it. If it doesn't reduce, here's where the slide part comes into play. We're going to slide that number over in front. And those would be our two factors. These two factors foiled together would get me back to here. And I should use m, not x, because I had an m in this problem, so that's my fault. M plus 1, 5m minus 2. Okay, and we're going to set both of those equal to 0. We get m equals negative 1. Here we're going to add 2, and we're going to divide by 5, and we get 2/5. And once again, these would be the two places that it would cross the x-axis. Okay? And in this case, it would be like at 0.4. So if you put it into your calculator, it should cross the x-axis at 0.4 and a -1. Okay, and there's one other type of factoring that I'm not going to talk about right now, but if we have some time towards the end today, I might show you a problem. It's called grouping, but it's different, and that's the one that uses the cubic polynomial, which I'm not really sure why they threw one in the mix, because this whole section is about quadratics, and then all of a sudden they throw in a cubic polynomial. So that's why I'm not going to necessarily talk about it right now, but we will talk about that as we go. Right now, I just want to focus on the quadratics and how to solve those. Okay, so that is our second method, is solving by graphing, solving by factoring, and there's like 3 different kinds of factoring, so you could count those as like a bunch of different ways, but they're all factoring in some shape or form, okay? And so I kind of lump those all together into one big category, factoring. Okay, this next one, this is the one that probably we've done the least, or at all. And like I told you, like we're going to be doing some of these, and you're going to get to choose what method you do on a lot of these, okay? There will be some where I'm going to say use this method to solve this quadratic equation. Completing the square is the one that we use the least out of all of these, okay? So I'm going to show you completing the square so you've been exposed to it, because there are some times where we use completing the square to do other things. So I think we need to at least talk about it, but just know that this is not going to be like our go-to method probably. This is going to be like at the bottom of our list of ways that we're going to solve. Okay, so I'm going to write out my equation. Okay, once again, we have another quadratic equation. And when I graph this one, I could see what my solutions is, but what I'm going to show you here in just a second is most of the time they are going to ask for exact solutions. And I'm going to graph this one here in just a second and show you that the answer is not going to be an exact solution. It's going to be a decimal when we graph it in our calculator. Okay? So completing the square is one of the methods that we could use to get that exact solution. So my first step is move the constant. The constant is the number without the x attached to it. So I add 10 to both sides because this is my constant. I add 10 to the other side. Now notice that I'm inserting some blanks into my equation. And that's why we call this completing the square. We want to complete this to be a perfect square trinomial. When we have a quadratic, we call this our a value, our b value, and our c value. Okay? And so when we do completing the square, my next step is to take the b value divided by 2 and square it. So that'd be like our second step. Well, in this case, our b value is -6. We're going to divide it by 2, and we're going to square it. So -6 divided by 2 would be -3. -3 squared is 9. But when we have an equation, whatever I do to one side, I got to do to the other, right? So that's why I draw a blank on both sides, because if I add 9 to the left, I also got to add 9 to the right. Okay, our third step is we're going to write this in the factored form, okay? So we could do product and sum. What multiplies to get 9 and adds to get -6? -3, -3, right? It's the same number that I get when I divide this by 2, -3, okay? And so instead of writing it as x minus 3 and x minus 3. I'm going to write it as x minus 3 squared because it's the same factor, okay? You could do x minus 3 and x minus 3, but I'm going to show you why we don't want to do that here in just a second. And then over here, we're just going to add the 9 and the 10 together, and we get 19. Okay, and then my last step, we are going to move the constant back. So we're going to subtract 19 from both sides. And that would be one way to write the equation. But what we want to do is we want to solve this, okay? And you guys might recognize this. This is what we call the vertex form of a parabola. We're not going to see that much today, and that's why I kind of show you that in some cases later down the line, we're going to use this to graph, okay? But for today, I'm going to move this down here now. We want to solve this. So we want to get x by itself. That's going to be our goal today, is to solve this equation. So instead of moving the 19 over, now we're just going to solve for x on this case, okay? So how would I get rid of the square? Take the square root. So we're going to do the square root of both sides. Okay. Whenever I do the square root of both sides, I'm going to put plus or minus on my answer. And then to get x by itself, we're going to add 3 to both sides. So this would become 3 plus or minus the square root of 19. That is our solution. Now I'm going to show you something real quick here, okay? Most of you would say, I just want to put this in my calculator and see where it crosses the x-axis, okay? Totally get that. That's probably what I would do as well. But if I were to do that, let's put this into our calculator. Let's take 3 plus the square root of 19. Type that into your calculator. What do we get?
Which version?
Round it to the nearest hundred. About 7.36, right? And if I do 3 minus the square root of 19, what do we get? We should get the negative 1.36, okay? So this is the exact answer. This is the rounded answer, okay? So it kind of depends on what the directions ask and how they ask us to express our answer. Are they the same thing? Yes, just written in a little bit different form. Kind of like I could write 1/2 or I could write 0.5, okay? One's a fraction, one's a decimal. They're different forms even though they're equivalent. Those are equivalent, just written in a different form. Okay. So completing the square will not necessarily be our go-to, but it will be something that we might use at some point in time to do some different things. Okay, so that is our third method today. You could just put it into the calculator and you could find those decimals pretty quickly like we did on that one there. And that our fourth method first thing I'm going to do here, and most of the time it's not going to be written like this. I haven't talked about this yet because every problem that we've done up to this point has already been set equal to 0. But if your equation is not set equal to 0, that has to be my first step. Set your equation equal to 0. Okay. Like I said, most of the time it will be, but if it's not, we got to get it in the format that we want it in. So we want it in that quadratic equation. I'm going to subtract 7 from both sides. And that would now be our standard form of a quadratic equation. 3x squared plus 2x minus 7. We always write the x squared first, and then the x, and then the constant. Okay, if you tried to do the methods that we've talked about here, okay, first of all, I know our go-to is probably going to be graphing, but if I ask you to write your answer as an exact value here, then it's not going to be an exact answer. Okay, and you would realize that once you graph it and you see the two places it crosses the x-axis or decimals. So if I tried all of the methods that we've talked about, could we try to factor this one? Maybe, but it would be slide and divide. Sometimes we like slide and divide. Sometimes we might say, I don't like slide and divide all that much. Okay, but what I will tell you before we even try it is that slide and divide would not work here. Okay, so I'm not even going to go to that point. You could try it, but it's not going to work. Slide and divide would not work here because my product is negative 21. My sum is 2. There is nothing that multiplies to get negative 21 that also adds to get 2. So slide and divide is out. And that would be the only factoring method available to us on this one. Okay, completing the square. I already told you that completing the square is not going to be something that we're going to choose most of the time, especially when there is a coefficient in front of x squared. I do not. I could show you how to do completing the square on this one, but you probably wouldn't want to see it because it's going to be messy and it's not going to be a whole lot of fun to do. Okay, so anytime I see a number in front of x squared, just know that completing the square is not a go-to method. But there is a method that we can use every single time, no matter what. If I can't factor, if I can't graph, if I can't do any of those things, what do you guys think it is? If only there was a formula that we could use to solve a quadratic equation. I wonder what we would call that. Just what you guys wanted to hear on a Friday, right? Our good old buddy, the quadratic formula, coming back into play. Everybody probably able to just recite that like nothing, right? Just like your ABCs. Jace? Yeah? Maybe? You're not brimming with a whole lot of confidence there. Just a maybe. Anybody think they can do it? Quadratic formula? Ryan says definitely not. No? Huh? Yeah, Armani, you got it?
Negative b plus minus square root of b squared minus 4ac over 2a.
Look at that. Good job, Armani. Good job. Just whips it out. Just like riding a bike, right? You guys remember that one? Unfortunately. So the good news, or bad news, however you want to look at it, is this formula will allow us to solve a quadratic equation anytime we want to solve a quadratic equation, no matter what type of quadratic equation we have. It may not be our go-to, but we know that we can always use the quadratic formula every single time. Okay? In this particular problem, we know our A, B, and C values, okay? And so A, B, and C, we always want to identify those. And then we're going to plug it into our equation, our formula. Because we're solving for x, that's our goal today, right? We're trying to find out what x is. We always start off with x equals whatever, okay? So we're going to go, and I always read this as the opposite of b. Don't read it as negative b because that might mess you up and you might think that it always has to be negative. It's the opposite of b. So if b is positive, it would be a negative 2. But if b was already negative, then this would be a positive. Okay, so that doesn't always have to be a negative number. Plus or minus the square root of 2 squared minus 4 times 3 times negative 7, all over 2 times 3. So we go through and we type in or we punch in our A, B, and C values. And then we simplify. Okay, where should we simplify first? I probably would not try to type this whole thing in my calculator all at once. Okay? Maybe it would work, but once again, most of the time when we do the quadratic formula, we're looking for an exact answer. Your calculator is not going to give you that exact answer, unfortunately. Okay? And so that's why we don't want to try to type it all in at once, because it's probably going to give me a decimal for my answer. Not probably, I mean, it will unless it's a nice whole number. So we're always going to simplify under the radical first. 2 squared is 4. The first number under the square root should always be a positive because you're always squaring it. Okay, this right here is probably the most missed part of when people miss the quadratic formula. This is usually the go-to. We got a minus sign here, and some people say, is that a minus sign? Is that a -4? You could do it either way, but you can't do both. Okay. So what I'll do here is I'll do 4 times 3 is 12. 12 times -7 would be negative, okay? And then this would be 4 minus negative, which would make it 4 plus. $84. All over 6. Okay, so we add those two together. We talked about this a little bit yesterday when we did i's. This is not an I because there's no negative under the radical, but I got to simplify this radical 88 to get it in simplest form. So what we did yesterday is we said, okay, let's look at our perfect squares. What's a perfect square that we have that would go into 88? 4, 16, 25, 36, 49, 64. Do any of those numbers go into 88? 4, okay? So what we're going to do and once again here, if you want to do the tree diagram where you break it down and do that, I don't have a problem with that. I think this way, at least for me, I think is a little bit easier. And you might disagree. You may like the tree diagram method, and that's okay too. But we know the square root of 4 is 2, so I'm going to bring that out. That leaves me a 22 underneath. And then to finish this out, both of these can reduce with 6. Okay? So we're going to start here. -2 over 6. I can take 2 out of both of those. Okay? And then I can take 2 out of both of these as well. You've got to take it out of both of them if you do that. And that equals 3, or over 3. Okay. This right here is what we call our exact answer. If it was just looking for the decimal answer, and you're going to have a couple of problems on your assignment today that are just asking you for the decimal answer, then it'll be okay, okay? But this one's asking for an exact value. That's the way we have to write our answer. Okay, one other thing that they're going to mention today. B squared minus 4ac go. B squared minus 4ac goes underneath the square root sign, right? So if I take the square root of a negative, what happens? What did we say yesterday? Square root of a negative is always an imaginary, okay? So if I have a negative underneath the radical, it will always be imaginary. So just understand why that takes place and why we have an imaginary solution, okay? And this kind of ties back to the quadratic formula. It's what we call the discriminant. And the good thing about the discriminant is we're not solving the equation. We are looking for how many and what type of solutions will we have. Way back at the beginning of the lesson, we talked about how many solutions we could have. It could cross the x-axis twice, which has 2 real solutions. It could come down and touch it 1 time, which has 1 real solution. It could never cross the x-axis at all, would be 2 imaginary solutions. So those are going to be our 3 possibilities. What type of solution and how many will there be? So the discriminant is b squared minus 4ac. So it's part of the quadratic formula. It's the part that's underneath the square root, right? B squared minus 4. It's not a new formula. It's part of the quadratic formula. So we're going to take that and we're going to look at the 3 possibilities. If the discriminant is equal to 0, we will have 1 real solution. If it's greater than 0 or positive, we will have 2 real solutions. And if it's less than 0 or negative, we will have 2 imaginary solutions. Those are our 3 possibilities, okay? So let's do a real quick example here. X squared plus 3x plus 4 equals 0. Okay, and I'm not asking you to solve this one. I'm just asking you to tell me how many solutions there will be and what type they're going to be. So once again, this is A, this is B, and this is C. B squared, so it would be 3 squared minus 4 times 1 times 4. So this would be 9 minus 16, which is negative 7. Okay, and then all we have to do is look and see which one of these 3 does it satisfy. It's definitely not equal to 0. It's definitely not greater than 0. It's negative. It's less than 0. So here we would say there would be 2 imaginary solutions. Okay. And just understand why, right? Because where does B, then I think it makes sense, and you don't necessarily have to memorize these types of solutions. It makes more sense. Okay. Assignment for today. I know I threw a lot at you today. There was a few other things that I kind of wanted to cover, but just time-wise, there's a lot of stuff in this section. So at the beginning of the lesson on Monday, we might cover a few things, or definitely before the quiz, we will cover some of those things for sure next week. Okay, on number 35, it says to solve by completing the square, but completing the square on that problem is one of those that gets really messy, so I would not do that. So on number 35, instead of completing the square, do the quadratic formula. Be a lot easier.